Welcome to Land Administration S'mores, where complex land issues meet campfire clarity. My name is Jack McKenna, geospatial consultant and land administration subject matter expert. Today we're going to discuss UAS and UAV system specifications. This is a draft summary for discussion only. System certification. Has UAS pilot been certified, and by what certification entity? What is the UAS fixed wing system model and country of origin? What is the UAS multi-rotor system model and country of origin? We're looking at a draft vendor questionnaire and calibration certificate information that was put together by me with insight into UAV and UAS sensor technology provided by drone subject matter experts Michael Detweiler of Wood Rogers Inc., Conrad Wright, Advanced UAS Services and Solutions, who provided information that system calibration and accuracy processes and parameters vary depending on the sensor type, processing workflow, and intended application. David Alamino, Matthew Hayes, and Eric Andelin of SimActive Inc. provided insight into how their LiDAR and photogrammetric processing software serves the UAS industry, and the questionnaire and calibration certificate information is below. What is UAV photogrammetry? UAV photogrammetry is a remote sensing technique where drones are used to acquire georeferenced imagery from low altitudes. The images, taken with high overlap, are analyzed using photogrammetric software to derive spatial measurements and orthomosaics and digital elevation models, DEMs. The advantages: high resolution data from low altitudes, rapid deployment and data acquisition. There are limitations: weather dependent on cloud, wind, rain, fog, or the absence thereof, limited flight time due to battery constraints. What is UAS LiDAR? UAS LiDAR is a remote sensing technology where drones equipped with LiDAR sensors emit laser pulses toward the ground. These pulses reflect off surfaces and return to the sensor, allowing the system to calculate precise distances and generate accurate 3D point clouds. The advantages: they penetrate vegetation to reveal bare earth. There's a high point density and accuracy, often within 5 centimeters. It operates day or night, not relying on sunlight. Limitations: expensive sensors and payloads. Shorter UAV flight time due to sensor weight. They require precise calibration and processing expertise. Sensitive to reflective surfaces, for example, solar panels, water, and glass. Dual LiDAR and photogrammetry collection. Dual LiDAR and photogrammetry collection offers the best of both worlds, with the simultaneous or coordinated acquisition of both LiDAR point clouds and photographic imagery from a single UAV platform during a single flight mission. LiDAR emits pulses for 3D geometry. The camera captures overlapping and geotagged images. Considerations: payload weight requires a robust drone. Data volume is high and requires large storage and processing capabilities. Calibration and synchronization between sensors must be precise. Post-processing software must support multi-sensor integration. Abbreviations, and these are familiar to all photogrammetrists, and they'll become very familiar to the client when he finishes or she finishes her project. Datum and coordinate systems. Horizontal: NAD 83 default US, based on GRS 80 ellipsoid. Vertical: NAVD 88, which will be transitioning to NAPGD 2022. UTM for nationwide mapping, metric coordinates. State plane coordinate system specific to each US state. Sensor calibration and accuracy. Does fixed-wing drone have consumer, that's hobby quality as found in Walmart, or industrial quality for surveying and mapping, IMU? Does USGS Eros, South Dakota, provide a sensor or camera calibration certificate system? Is lab calibration a good option? Date of most LiDAR sensor and camera calibration? What is the LiDAR or photogrammetry data order of accuracy? First, second, or third? That you used to get with aerial film cameras, and those data accuracies are not available anymore. For some reason, not for UAVs. Perhaps they should be. How many LiDAR sensors? How many LiDAR sensor looks, vertical, front, rear, side, left, side, right? Data capture and product. What is the optimal GSD? That's ground sample distance at the pixel size. You require LiDAR point cloud or photogrammetry digital surface model, DSM, or both. Do you want a dual collect option, LiDAR plus IMU DSM? GCP, ground control point requirement. Do you need one or more? Is true ortho required? Yes or no? What is the area mapped by one UAS pilot in one day? Is high oblique or low oblique camera imagery required? Flight and equipment. What is the project flight altitude? What camera sensor image bands are required? Is LiDAR UAS capable of dense foliage penetration? Is GNSS/IMU sensor of high quality? What is selected UAS photogrammetric AT or aerial triangulation software? For example, SimActive Correlator 3D or Trimble Applanix. Accuracy, cost, and reporting. What is the delivered UAS map accuracy? What is the cost range per acre for UAS mapping? What is UAS LiDAR sensor model and country of origin? What is UAS LiDAR software country of origin? What is the LiDAR vertical accuracy? Confirm the LiDAR QC check shots. What is the UAS accuracy reporting format? Compliance and permissions. What is the UAS standards body, for example, ASPRS? Has permission been given to download LiDAR and photogrammetric data to country of sensor origin? For example, DJI, the Chinese UAV? Yes or no? Has permission been given to download LiDAR and photogrammetric data to TikTok? Yes or no? So, additional comprehensive land information is available in the Jack McKenna book, a land administration toolkit available on Amazon. I can be contacted at jack_McKenna@landdataplus.com. Thank you for your time and attention.